Welcome back to Science 10. This is the final part of CD2. So you would have just finished the greenhouse effect activity, and the last part here is looking at the net radiation budget. So Earth is a warm, habitable planet because incoming solar radiation is absorbed by the Earth's surface and the atmosphere. However, not all of the incoming solar energy is absorbed. Some is reflected out to space, and some is re-emitted as thermal energy by the Earth's surface and atmosphere. Therefore, we have something referred to as the net radiation budget, which is the difference between the amount of incoming radiation and of outgoing radiation re-emitted from the Earth's surface and atmosphere. Incoming radiation is all the solar energy that reaches the Earth surface, not including the solar radiation that is reflected by the atmosphere and by the albedo of the Earth's surface. Outgoing radiation is the thermal energy re-emitted by the Earth's surface and atmosphere that is not absorbed by the greenhouse gases of the atmosphere. So it actually leaves the area of the Earth. The net radiation budget can be written quite easily as the budget is equal to incoming radiation subtract outgoing radiation. So of course, what would you expect the Earth to be then, if that is the case? Here's kind of a breakdown of incoming and outgoing radiation. So incoming solar energy, if we assume that's 100%, of course 6% is reflected by the atmosphere, 20% reflected by clouds. Part that hits the Earth, some of that is reflected back from the Earth itself. 16% is absorbed by greenhouse gases. Out of that 16%, 64% is re-emitted from the atmospheric gases and clouds. 3% is absorbed by clouds, and you can see how all this works. So just a quick rundown. It shows all the different amounts that are reflected or absorbed. So some is immediately reflected back into space by the atmosphere, clouds, and the Earth's surface. The remaining incoming radiation is absorbed by greenhouse gases in the atmosphere and clouds and the Earth's surface. On average, all the energy absorbed by the atmosphere, lithosphere, and hydrosphere is eventually emitted and radiated back into space as thermal energy. Absorbed solar energy is radiated from the clouds and atmospheric gases by phase changes in the hydrosphere, etc., etc. Now, so what does that all mean? In the long run, the average of the incoming radiation is equal to the outgoing radiation for all of the planet. So for the planet as a whole, incoming equals outgoing, so the change is zero. If this balance were to change, then the average global temperature would either increase or decrease until the net radiation budget was balanced again. For example, if the amount of radiation re-emitted back into space were to decrease and the amount of incoming radiation remained the same, Earth's average global temperature would increase, of course. Although the net radiation budget is balanced for Earth as a whole, some regions on Earth have an unbalanced net radiation budget. So as we've seen, latitude is an important factor. For example, the polar regions tend to have lower insolation, so a less amount of solar energy is reaching near the poles. And of course, because it's snowing up, we have snow on the ground up there, there's a higher albedo, so reflection. So as a result, there's less incoming than outgoing. So there's an imbalance there. The poles always have a net radiation budget deficit. Regions near the equator have a high insolation. They receive a lot of sunlight. There's no snow there, so there is little reflection back into space. So most of it is absorbed, which results in more incoming than outgoing. So regions on or near the equator always have a net radiation budget surplus. If the only factor that determined climate were differences in net radiation budget, then we would see the average temperature in regions with the net radiation budget surplus, such as the equator, would be expected to increase over time since the excess radiation would be converted to thermal energy. Similarly, regions with a net radiation budget deficit, such as the poles, the average temperature would be expected to decrease over time. But of course, we really see that does not happen. So there are other things that happen. So thermal energy is transferred from latitudes with net surplus to net deficit. So of course, air currents and other things transfer that excess thermal energy from the equator to the poles, and it circulates around until we have a no deficit, and it works out to be equal. All right, so that marks the end of CD2. We'll see you again.